If you've ever built a sword, a spell, or an ability in Roblox, there's a good chance your targeting system is broken, even if it mostly works. You might be using mouse raycasts or distance checks, or both mixed together. And eventually you hit problems, missed targets, wrong enemies, or the server rejecting hits that look fine on the client. In this video, I'm going to show you the correct architecture for targeting systems in Roblox, the same structure that works for combat, abilities, tools, and NPC interactions. No gimmicks, no hacks, just the right mental model. The problem with most targeting systems isn't the math, it's responsibility. Most systems try to do too much at once. Selection, validation, damage, effects, all tangled together. So let's look at the two most common approaches. First, mouse-only targeting. You raycast from the camera or mouse, and whatever you hit becomes the target. It feels precise until it doesn't. NPCs don't line up with the mouse, abilities feel inconsistent, and the server can't trust it. Second, distance-only targeting. You find the closest enemy within range, it's reliable, but it feels random. Players feel like they're hitting enemies they weren't aiming at. Both systems return a target, but neither reliably returns the correct target. Here's the mental shift that fixes everything. Raycasting does not select a target, it selects a candidate. Distance checks do not select a target either, they select candidates. The real job of a targeting system is to answer one question: what is the best target right now? And that means we need both precision and forgiveness without trusting either blindly. This feels good because the system preserves player intent. If you aim at an enemy and slightly miss due to animation, latency, or camera movement, the game doesn't punish you. It rescues that intent without taking control away from you. That's the difference between forgiveness and auto-targeting. This is the correct flow. First, we try mouse raycast. If it hits something valid, great, that feels precise. If it hits something invalid like a wall, the ground, or a non-targetable NPC, we don't fail. We fall back to distance targeting. And only after that, we validate the final target, range, line of sight, tags, alive state, everything. The targeting system does nothing else. It doesn't deal damage, it doesn't play effects, it doesn't animate, it answers one question and stops. Now this is where most Roblox games go wrong. The client is allowed to feel good, the server is allowed to be right. On the client, I'm hovering over a wall. The mouse cast hits the wall, which is invalid. So the client falls back to distance targeting and selects the nearest valid enemy. That's intentional. That's good UX, as it feels right for the player. UX is whether the game makes sense while you're playing it. You can see here, client target equals a target. Now watch the server. The server recomputes the same targeting logic but with stricter rules. Line of sight is required on the server, and the server says blocked line of sight. Client suggestion ignored. Server truth wins. And that's exactly how it should be. This architecture solves all these problems at once: combat targeting, ability targeting, tool interactions, NPC logic, anti-exploit validation, You don't write a new targeting system per weapon, you write one system and configure it. Range, tags, line of sight, target types, all data, not code. Get best target handles selection only. Validate target handles rules only. The client previews, the server decides. This separation is what makes the system scalable, testable, and secure. If you take one thing away from this video, let it be this. Targeting is not about finding something, it's about choosing correctly. Mouse raycasts are candidates. Distance checks are candidates. The server is authority. In the next video, we'll build abilities on top of this system without rewriting a single targeting rule. If this helped you, like the video and I'll see you in the next one.